Hi students, this is AJ sir. Let's study 10th standard ICSE Math chapter 6A, Word Problems of Quadratic Equations, part 1. Chapter 6, Quadratic Equations, Word Problems. Exercise 6A. Let's start with the second question. The sum of the squares of two consecutive natural numbers is 41. So we'll assume the two consecutive natural numbers to be x and x plus 1. And the sum of their squares is 41. So that's how we get the quadratic equation. Now when you open the brackets, if you use the formula a plus b the whole square, we get a square plus 2ab plus b squared. Rearrange the terms to get the quadratic equation, divide by 2 to simplify it, splitting the middle term so that you get two values of x. The negative value won't be accepted, hence the numbers are 4 and 4 plus 1 is 5. Next, the fourth sum. The sum of a number and its reciprocal is 4.25. Find the number. So again, let the number be x, so its reciprocal is 1 upon x, and the sum of the two is 4.25. Convert the decimal into a fraction, LCM into x, so that they have a common denominator. Cross multiply to get a quadratic equation, splitting the middle term, and we get two values of x. Now if x is this, then the reciprocal is 1 upon 4. And if x is 1 upon 4, then the reciprocal is 4. So the required number is either 4 or 1 upon 4. Both are valid answers in this case. The sixth sum. Divide 15 into two parts. So let the two parts be x and 15 minus x. We don't use two variables. We don't use x and y in this chapter for most of the sums. Now it is mentioned that the sum of the reciprocals is 3 upon 10. So again we'll do LCM. So this will become into 15 minus x into 15 minus x, and this will become into x into x. So we have a common denominator, get the numerators together, open the brackets, cross multiply and get the quadratic equation, simplify it by dividing by 3, splitting the middle term, and we get two values of x, and both are acceptable. So the required numbers are 10 and 5 because their sum is 15. Now the first number could be 10 and the second number could be 5, or vice versa. That doesn't matter. This is the answer. Next, the eighth question. The sum of the squares of two consecutive positive even numbers. So we will assume the two numbers to be x and x plus 2, because the difference between two even numbers is 2. If they would have asked two consecutive odd numbers, then too we would have assumed them to be x and x plus 2, because if one odd number is, let's say, 3, what is the next consecutive odd number? It's 5. So what's the difference? Again, it's 2. So the difference is 2. So whatever is the first odd or even number, the next consecutive odd or even number will also be x plus 2. And the sum of their squares is 52. So now opening the brackets, we get a quadratic equation. Splitting the middle term, factorization method, we get two values of x. Now the negative value is not possible because in the question they've mentioned positive even number. So we have to accept this. So what will be the next consecutive even number after this? 6. So the required numbers are 4 and 6. Next, the 10th sum. The denominator of a positive fraction is 1 more than twice the numerator. So the numerator is x. So the denominator will be 1 more than twice the numerator. So understand how the English sentence was converted into a mathematical expression. And now it's mentioned that that fraction, see, this is the numerator and denominator, plus its reciprocal. So the reciprocal of this fraction is this. And their addition is 2.9 as per the question. So again, LCM into x into 2x plus 1 into 2x plus 1, so that we can get the two fractions together. Open the brackets, square formula. Open the brackets, the denominator as well. Get rid of the decimal place. Cross multiply, open the brackets, rearrange the terms to get a quadratic equation. Splitting the middle term, we get two values of x. One is a negative number and in fact a fractional value, which is not possible. So we accept the value of x as 2, and now the required fraction will be 2 as a numerator and denominator will be 5. So the answer is 2 upon 5. Next, the 11th sum. 3 positive integers or numbers are in the ratio 1 upon 2, ratio 1 upon 3, ratio 1 upon 4. It's a very complex ratio. We'll have to simplify. For that, we'll remove the LCM of the denominators. We need to get rid of the denominators. So the LCM of 2, 3 and 4 is 12. So multiply the ratio entirely by 12. So this into 12, this into 12, this into 12. By doing this effectively, we are not changing the value of the ratio. We are just simplifying it into 6 ratio 4 ratio 3. So this ratio is actually the same as this one. It's just that this is more complex. Once we get the usual ratio, we can let the numbers be 6x, 4x and 3x respectively, where x is the common multiple. And now as per the given condition in the question, the sum of the squares of the 3 numbers is 244. So we solve this and get the value of x plus or minus 2. But they mentioned positive numbers, so we'll accept only 2 as the correct answer. And so the 3 numbers are 12, 8 and 6, because if you substitute 2 here as x, then you'll get this answer. Now the 14th question. Out of 3 consecutive positive integers, the middle number is p. So here we won't assume it to be x. It's already mentioned that the middle number is p. So if the middle number is p, then obviously the smaller number will be p minus 1 and the greater number will be p plus 2. These are the 3 consecutive positive integers. Now as per the given question, it's mentioned that 3 times the square of the greater number, or 3 times the square of the largest number, is greater than the sum of the squares of the other 2 numbers. That means if I take the sum of the squares of the other 2 numbers, and if I take 3 times the square of the largest number, then this 3 times the square of the larger number is greater than this. And the difference between them is 67, because in the question it is mentioned that this is greater than this by 67. So let's read it again. If 3 times the square of the largest number is greater than the sum of the squares of the other 2 numbers by 67, that means their difference is 67. Whose difference? On one hand we have the 3 times the square of the largest number, and on the other hand we have the sum of the squares of the other 2 numbers. This one is greater than this one by 67. So that's how we got this equation. And once we get the correct equation, then the rest of the sum is pretty straightforward. Now notice that when these square brackets are removed, this sign will change. It will also become negative because there is a negative outside. Simultaneously, I am opening these brackets. So this will be p square plus 2p plus 1, that is a plus b the whole square formula. Even here, this will become a minus b the whole square formula. Don't open the brackets yet. And notice how this sign has changed. The plus out here has become minus. Now open the brackets further. So distributive multiplication here. Here we have minus outside, so all the signs will change. This will become minus p square plus 2p minus 1. This will remain as it is. And now get all the like terms together and we get a quadratic equation. Splitting the middle term, we get 2 values of p. The negative value is rejected and we get the positive value of p as 5. If they would have asked us for the 3 consecutive numbers, it would have been 4, 5 and 6, because remember, p was the middle number. So mark the 11th and the 14th, 16th and 17th sums as IMP. Now the 16th sum. one pipe can fill a cistern, that is a tank, in 3 hours. 3 hours less than the other one. So let's assume the two pipes are A and B. So A seems to be taking X hours, and B, let's assume, is taking X minus 3 hours to fill the same cistern. If both the pipes work together, they can fill the cistern in 6 hours and 40 minutes. Find the time each pipe will take to fill the cistern. So this type of sum is a work and time type of sum. So I like to use the table method to solve such sums instead of writing complicated statements. So pipe A can do one whole work, that is of filling the cistern, in X hours. That's an assumption. So in 1 hour, how much work can be done? 1 upon X. It's always a reciprocal. Let's give an example. Imagine you can read one whole novel in 10 days at a constant speed. So how much of that novel, what fraction of that novel can you read in 1 day? 1/10 of it, isn't it? So that's how it's a reciprocal. So in X hours, if you can do one work, then in 1 hour, you can do 1 upon X work. Similarly, let's assume B does that same one whole work in X minus 3 hours. It's mentioned that one of them takes 3 hours less, so B is faster. So in 1 hour, it can do 1 upon X minus 3 work. So if both the pipes are open together, in 1 hour, they can do 1 upon X plus 1 upon X minus 3 work. So that's the total work, 1 hour work. This is the 1 hour work. However, they have also mentioned that together, they can complete the entire work in 6 hours and 40 minutes. So please convert it into hours. That's 6 hours and 40 upon 60 hours. That's 62 upon 3 or 20 upon 3 hours. So A plus B together, both the pipes together, can complete that work of filling the cistern in 20 upon 3 hours. So in 1 hour, how much work can they do, or how much of the cistern can they fill? Reciprocal of this, that's 3 upon 20. So this is A plus B's 1 hour work. So this is A plus B's 1 hour work according to the given data, and we have found A plus B's 1 hour work in terms of X. So definitely these two are equal, and that's how we get our quadratic equation. This is A plus B's 1 hour work. And then just solve them usually, LCM, cross multiply, open the brackets, splitting the middle term, and get two values of X. This value of X won't be accepted because if X is 4 upon 3, that's fine. But then X minus 3 will become a negative value. How can B do work in negative time? That would mean that it's traveling back in time. That's not possible for pipes unless it's being used by flash or something traveling faster than the speed of light, which has not been stated in the question, so we can't use such assumptions. We'll accept X as 15. So pipe A takes 15 hours and pipe B obviously will take 3 hours less, which is 12 hours. Now the 17th sum. A positive number is divided into two parts. Again, two parts, but here we will have to use X and Y because the conditions are such that the sum of the squares of the two parts is 20. That's one condition. Second condition, the square of the larger part is 8 times the smaller part. And they have mentioned take X as a smaller part. So if we take X as a smaller part, let's assume that the larger part is Y. So according to the first condition, the sum of their squares, that is X squared plus Y squared, is 20. And as per the second condition, the square of the larger number is 8 times the smaller number. No square out here. So that's how you got two equations in X and Y. Now this value of Y square, 8X, we shall substitute out here. So that way we can get the entire equation in terms of X. So y has disappeared, and now we can solve this. This is a normal quadratic equation. And then split the middle term and get two values of x. The negative value is not possible, so we get the smaller part, and the larger part is obviously y square is equal to 8x is equal to 16. But that's the answer of y square. From this we get the value of y, and remember that y is the larger part, not y squared. So again, the smaller part is 2 and the larger part is 4. But they have asked for the number which was split into 2 and 4. You see, 2 and 4 are the small and the large part of a number. What is the actual original number? It will be 2 plus 4, which is 6. So that's the final answer. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.